Welcome, Hot Wheels fans, to the follow-up video on modifying Hot Wheels power boosters to run on AC using a simple AC to DC adapter. If you saw my earlier video, you remember this booster, which we had modified with a 5.5mm socket to run off a AC adapter. Let's take a look at the inside here. This was done with a simple 2-pin socket, and leads were wired directly to the battery terminals, positive and negative, to allow it to run on AC. So that was a simple mod, but it has a problem in that it's possible, if batteries are left in the battery compartment when it's run on AC, that the direct current voltage that's being applied here will go not only to the motor, but will also go to the battery compartment and could result in overcharging your batteries and cause them to overheat or even explode. So that's something you want to be careful of. If you did use a 2-pin socket, you don't want to have batteries in there while it's also running on AC. However, we can make this much safer, and I'm going to show you how to do that right now. The key to making this safer is using a 3-pin socket. So this is very similar to the 5.5mm socket that we used here. You can see that. But on the back side, it's different. It has an additional pin. Instead of 2, there are 3. The third pin detects when a plug is inserted, and what it does is it allows a second power supply to be used, and it will isolate that second power supply when the plug is inserted. Might be able to illustrate what I'm talking about with this simple drawing here. I'm not much of an artist, but hopefully this will help. So these images here are the back view of the pin. So you can see we have a pin on the top, a pin on the left, a pin on the right. When your AC adapter plug is inserted, you'll have negative here, positive here, and this pin will be isolated. So this is where your battery compartment is going to be connected. When the plug is pulled out, there's a contact that closes, so the battery can feed from this pin to that pin. So by simply inserting these 2 pins in the wiring from the negative side of your battery to the negative of the motor, it will act like a switch. And when the plug is pushed in, it will isolate the battery compartment. And when the plug is pulled out, it'll close that contact internal to this little socket and allow the battery to feed the motor. Let me show you what that looks like with a demonstration using snap circuits. Here we have a representation of the Hot Wheels booster. We have a battery pack, we have a simple on-off slide switch, and we have a motor. I've simulated wiring the plug socket here and attached some leads, and this is how it would be wired in your booster. So one lead going to the negative side of the battery, and then the other pin, the black wire, going to the negative side of the motor. The positive lead from the socket is going onto the positive lead of the battery. So with no plug inserted, so here's our 6-volt power supply plug. I'm not going to put that in right now. Let's go ahead and turn it on, and you can hear the motor and see the motor is turning with the 3-volt battery supply. If we push in this socket, or this plug rather, and this is applying 6 volts, so we should notice an increase in speed on the motor. And there it is, wound up to 6 volts. And you can see by simply pulling that plug out, the motor goes right back onto the battery supply, onto AC, back on batteries. So very convenient, and safely isolates the batteries when the plug is inserted. And how do we know that the batteries are isolated? Very easy to check. So with the 6 volts still being applied right here, let's bring in a little multimeter here. Take these pins off here. So there's the positive. And there's the negative side. Let's set our multimeter to measure DC volts. And let's check and see what we have here. And sure enough, there's no voltage being applied to the batteries. However, we do have voltage here, and you can see that on the socket, but it has safely isolated the batteries. So let's take a look at a booster that's actually been modified with one of these 3 socket pins. Here's a power booster that had such a modification, and let me see if you can see closely there. The 1, 2, 3 contacts there. One contact going straight to the negative of the battery terminal. The other contact going to the negative side of the motor. And the third contact going to the positive of the switch, which is right back in there. Here's another booster that has been modified to run on AC. Very similar situation here. You see the 3-pin socket in there. And you can also see that, if you can get close enough in there, that the wiring has just used the 2 pins on that socket to intercept the wiring going from the negative side of the battery to the negative of the motor, and the other socket pin was tied directly to the positive of the battery terminal. So hopefully you can get a view of that. I know it's kind of crowded in there. But that's it. That's how simple it is. Here's another view of this little illustration I made. And again, you can see for this particular pin, now these 3 socket pins come in a variety of configurations from different vendors. So I verified with a multimeter with the power applied to make sure which one of these was the negative, which side was positive, and which side was isolated by the contact. But with this particular type, which is pretty common, you can purchase these on eBay for probably 10 cents or less. You would wire it with the left-hand pin, again looking at the back side of the socket, the left pin to the motor positive, and of course you want to make sure it's on the correct side of the switch, so the switch will still turn the booster on and off. The top pin to the motor negative, and the right-hand pin to the battery compartment negative. And that should do it for you. So have fun with your Hot Wheels booster mods with this safer version using a 3-pin 5.5mm plug adapter. Thank you.